it's time to discuss how big should capital N be? How many bootstrap samples should we take? This is going to be probably the most technical and most hand-wavy of the lectures that I've given so far, but I decided this was a question that merited enough effort for me to go through this. So we're going to be talking about the coefficient of variation. Okay, so let's remind ourselves what N is. We have a population. We sample from this population with a sample size of lowercase n. So we sample from this population with a sample size of lowercase n. And from this sample, in order to construct, for example, a bootstrap confidence interval, we take lots of bootstrap samples. Each of these bootstrap samples will be, so these are bootstrap samples, will be size n. However, we will be taking capital N of these bootstrap samples. So how big should this capital N be? I'm going to go ahead and just sort of tell you this, so you can pretty much cut the video right after I say this. So as a rule of thumb, having N be around 10K is it's just generally good enough. There will be rare cases when N needs to be bigger than 10K. So let me sort of go about why this might be. So one way we can go ahead and we can measure this is by looking at the coefficient of variation. And so the coefficient of variation is how varied will our confidence interval be. It's kind of like a measure of that, given we took N, capital N, bootstrap samples. And you would notice if you went ahead and you plotted this curve, it would look something like this. Okay? And so this curve steeply descends at first and then flattens off, almost asymptotes. And if you actually plot at points here, these points might be something like 10, 250, 500. So in fact, there is a closed form formula that can give us an approximation of what the coefficient of variation would look like. And this formula looks something like this. It says CV is approximately some function of alpha, okay, some function of alpha, where alpha is what is your confidence interval. If your confidence interval is a 0.9% confidence or a 99% confidence interval, this function would get bigger. The smaller the confidence interval, so in this case, if it's a 90% confidence interval, this would get smaller, times 1 over n plus 1 over big N to the 1/2. So notice the variation decreases as n gets bigger, and it decreases very quickly during the first few n. That being said, because we take a square root here, the subsequent increases of n aren't going to matter as much. So you can go ahead and you can calculate this technically for each of your confidence intervals that you'd be interested in. In addition to this function of a, there's also a coefficient. There's some coefficient which we can call c, and this coefficient depends on the kurtosis and also depends on the skewedness of your distribution. So it depends on the higher moments of your distribution. So this is pretty complicated. I will link to you some interesting stuff that you can read up on this, and perhaps I might make a function that might go ahead and tell you, based on the empirics of your distribution and the confidence interval that you're looking to create, what should the number of samples be. So this might be in a Python library or something like that. And you can go ahead and look up this yourself. But I'm going to sort of leave it at 10K is generally good enough. Going more than 10K is generally superfluous. The problem is if you're doing with a very long function, so you wanted to generate a confidence interval and training a neural network or something like that, 10K becomes really, really big. So anyways, please contact me or please comment below if you've got any more questions. I know this was very high level and very technical, but I just wanted to go ahead and answer this question. Thanks, guys.